Hello. So, briefly, the instruction on how to use the SkyViewer. So, first of all, you go to betacontrol.skymapper.io/login. You enter your password that we sent you. And here you are on this interface that basically allow you to see which telescopes is connected to the network. So the gray dot implies that the telescope is available. I will say 90% of the time because we still have some issue to fix. The red dot means that the telescope is not available because it's not outside, it's not turned on, or for some other reasons, or the user is using it. So I know that Mario telescope in Vienna is available. So I click on it, then I connect, and then you can see that Mario is located in Vienna here. So the first thing to do generally is to look to capture an image and check if there is stars, just to be sure. So there is stars here. This will be automatic in the future. Then you do what we call auto alignment. That will be also automatic in the future, but that's basically the way for the telescope to align itself to find the right pattern of sky and to be able to say where is the target. So then you can choose a target. So there is multiple way to choose a target. You can enter the input manually. We're not going to do that. You can also choose a target among a long list of targets here. I recommend you click on the visible in your sky area. And one of the targets that I generally recommend is M27. Let's see, sorry. M27 is a nebula. It should be visible. Here we are, Dumbbell Nebula. You click on that, done. Then you go to coordinate. So here the telescope is moving now to the coordinate. When you see this, it means that something is happening with the telescope. You can go at the show log if you're very technical to see, to have some information about the telescope itself, the motion, etc. But I don't recommend you do that. You wait. It can take up to 2 minutes, depending of where the target is located with respect to the place of the alignment. So you wait. This is a great time to have a drink or wait or talk to people about what this interface is all about. Comment a success. It does work. And now you can start what we call the enhanced vision, which is the algorithm to take observation and stack them and remove the noise, etc., developed by Unistellar. And it's working. So right now, what you can see here, the telescope is observing, meaning that it's taking observations every 4 seconds, a new frame, and it's stacking them. So if you can capture an image, and you will see one of the first image of this object. Here it is. So here we're observing from Vienna the Dumbbell Nebula, and you can barely see it here. So you can wait, and we're gonna do that. We're gonna wait, let's say 2-3 minutes, and the image gonna get better as the telescope is acquiring more data. So this is the way we basically use our telescopes. Unistellar has developed this algorithm, but a type of algorithm has been developed for other type of telescopes. So we'll be able to integrate other telescopes in the future using the same kind of technology. Let's wait a bit more. In the meantime, we can visit AstroViewer. I think it will work. So it shows you that the last observation taken on chain was taken from Vienna, and that's this observation. So you can zoom out. You can see that we have observation taken last night from my telescope. It was foggy. No, that was from Tom telescope. It was foggy, so we have no observations, but no stars. And maybe we have Japan. I think Japan was active yesterday, but no, not in the latest 80 observations. That's what we show here. Let's go back to our SkyViewer. So we capture another image. And here you can see it's getting significantly better. Okay. We are in the middle of Vienna here, downtown Vienna. So of course this image is not like super flashy and colorful. Plus, this is the first generation of telescope of unistellar. So we call the EVscope 1. So it's less sensitive. There's an algorithm which is not as powerful as the EVscope 2, hence the kind of pale color you have here. But seeing something like this from a city, it's remarkable with such a small telescope. This is the telescope, basically, that we are using. Slightly bigger, the EVscope 1, but that's basically the kind of telescope we're using. Okay, what can I show you? I can show you the SkyChain Explorer. This is basically the all the transaction done on chain. We are on Avalanche at the moment, as you know. This is really the part that I'm still learning about. You can see the hashtag, you can see some information about the data itself, and so on. We have not yet done, of course, the tokenization. That's something that we will implement in the future. And let's take another picture. And we can end here, maybe. Here we are, significantly better and more colorful. Depending, of course, remember that depending of the time of the observation, you don't know what data will be, what telescope will be available. So you need to look always here and hope for someone among the 10, 20, I think it's 12 now, beta tester we have the telescope outside and the weather is clear as well. So when you're done, you can stop the observation. And then you can upload them. And those observations are going to be sent, each frame, one per one, will be sent to Akave and store on chain and store there. So we can run a posteriori more complex data processing, do analysis of the data, etc., etc. So this take a while. I think we have 68 observations here, but you will see that the last one is always the best frame because the last frames is basically the combination of all the frames stacked together. So that's what you will see with a normal telescope. So you have an idea. Okay, you barely see the object here. And the transaction will appear here on this as the data being uploaded on Akave. So yeah, it does work. We now can control the telescope anywhere in the world on chain using our system. There is some improvement to make, such as being able to visualize where the telescope is, being able to automatically say there is no star because you're pointing the telescope to a tree, a house, or something like that. Maybe also have some kind of a smart way to tell you what object you can or you cannot observe. But we have built the infrastructure that allow us to control any telescope connected to our platform from any part of the world and store this data on chain so we can do a posteriori analysis and so on. I'm gonna wait for the last frame. Hopefully it's gonna be what I expect it to be. And this will get faster as the network grow and the number of sky bridges increase, of course, because the processing and And basically there will be redundancy to improve the uploading speed and the processing itself. Okay. Patience. You don't have to watch all of this, so. Okay. Ten more. Yeah, astronomy is you have to be patient sometimes. We bypass this by doing astrophotography live with our telescopes, but for the scientific analysis, you really have to be patient and be able to upload all the data, all the frame rate per watt. So this is the outreach part. It's basically getting a very pretty picture from any part, from the telescope, any part of in the world. Something I'm not going to show you because it's take way more time and it's not that interesting is how you can also do scientific observations. There is not the nice frame that I was expecting, so I basically was wrong on this one, but they may have changed that. Another time. Thank you. Bye-bye.